Today's lecture is on adding and subtracting radical expressions. Example 1 wants you to subtract square root of 25 minus the square root of 16. So first, I want you to observe that you cannot subtract the square root of 16 from the square root of 25 as it is, right? So this does not equal to the square root of 9. Just want to make it clear, this does not equal to the square root of 9, right? You cannot subtract them. So the only way you can add and subtract is if you have like terms. These two are not like terms. They'll be like terms if what's under the square root is the same. So since this one has 25 and this one has 16, they're not the same, so they're not like terms. They have to be exactly the same to be like terms. So don't try to subtract 16 from 15 in this case. It does not work. So what's the proper way to do it? Well, first, you can try to evaluate the square root. For example, what is the square root of 25? What number times the cell gives you 25? Well, that's 4. I'm sorry, 5. I'm doing the square root of 16. So that's 4. Again, I said 4. That's 5. And then minus, what's the square root of 16? Well, that's 4. So the square root of 25 minus the square root of 16 is 1, right? So you have to remember, don't get caught up trying to subtract the 16 from the 25. You can't. Yes, 25 minus 16 is 9, but the square root of 25 minus the square root of 16 is not the square root of 9. You have to apply the square root first. So you have to do what's under the square root first, right? All right, so 1 is the answer for the first problem. Now, the second problem, example 2, which says subtract 5 times the square root of 2 minus 3 times the square root of 2. So now observe that these are like terms because the term under the radical, in this case, square root of the square root, is the same, right? 2 and 2. So in that case, they are like terms. So we can we can follow the operation, in this case, subtraction. All right, so basically we have 5 of square root of 2 and we have 3 of square root of 2. Or it's sort of like you have $5 and you want to subtract $3, right? So because these guys are the same, this and this is the same, when you're adding and subtracting, you don't change them, you just work with the coefficient, the numbers in front. So we're just going to subtract the 3 from the 5, right? So bear in mind, this is similar to 5x minus 3x, right? The x's are the same, so you just subtract the 3 from the 5 to get 2x. So that's what we're going to do here. I'm just subtracting the 3 from the 5 to get 2 square root of 2. So I'm doing nothing with the square root of 2. I just need them to be the same. So the answer is 2 square root of 2. So only if these guys are the same, exact same, means that what's under the square root, the radicand, is the same as the radical. In this case, it's a 2. But you could change to 3 or 4 or 5, but they have to be exactly the same in order for you to add or subtract. Okay, for example, number 3, we said simplify 15 times the cube root, right? When there's a number here other than 2, you have to put the number. So this one is square root. There's a 2 there, but we just don't write it, right? So this one is cube root of 2. So 15 times the cube root of 2 minus 10 times the cube root of 2 plus 7 times the cube root of 2. So notice that they all have cube root of 2. So that means they are like terms, right? This is the same exact thing as this. and the same like this. So we just need to look at the coefficients. Just need to sum up the coefficients and we're done. So first you need to figure what is 15 minus 10. So 15 minus 10 is just going to be 5. So you get 5 cube root of 2 plus 7 cube root of 2. And now you just need to add the 7 and the 5 together, which will give you 12 cube root of 2. And you are done. All right, so bear those examples in mind as we move to the next one, which is example 4. So example 4 wants you to add the square root of 8 to the square root of 18. Again, just look what's under the radical. 8, 18, they're not the same, so you cannot add them just as it is. You have to somehow simplify it first, or you have to apply the radical first. So what's the square root of 8? Well, there's no number times itself that gives you 8. But we can simplify it. Is there a perfect square? A perfect square is a number times a number. So for example, 4 is a perfect square because it's 2 times 2. Or 9 is a perfect square because it's 3 times 3. And you get the picture. 16 is a perfect square because it's 4 times 4. So is there a perfect square times another number that gives you 8? And the answer is yes, because 8 is 4 times 2. Remember, 4 is a perfect square. So now you tell me, what perfect square times another number that gives you 18? So if you say 9, good job. 18 is 9 times 2. The reason why we want perfect squares is that we can take the square root of them. So we can rewrite 4 square root of 4, the square root of 4 times 2 is the same as the square root of 4 times the square root of 2. And the same thing, the square root of 9 times 2 is the same as the square root of 9 times the square root of 2. Right? You have to take the square root of both of them. And we know what the square root of 4 is. The square root of 4 is 2. So this is 2 square root of 2. And the square root of 9 is 3. So this is 3 square root of 2. So now notice what happened. You end up with square root of 2 in both of them. Now they are like terms, right? Because there's 2 square root of 2 and 3 square root of 2. So you have 2 of something plus 3 of the same thing. So that's how you get your answer. Your answer is going to be 5 square root of 2. When you take the 2 and you add it to the 3. Mhm. All right, so let's look at example 5. All right, so you want you to add the 2 times the square root of 12 plus 5 times the square root of 27. Same thing, right? You cannot add right now because 12 and 27 are not the same. So what you need to do, you have to simplify. So you have to figure what perfect square times another number that gives you 12. So you have to know that 12 is the same as what? 4 times 3. Of course, you can say 6 times 2, but 6 is not a perfect square, so that's why we're not using 6 and 2. We're using 4 and 3 because we can't take the square root of 4. So you cannot just use any number that you can multiply to give you 12. You have to use one of them must be a perfect square. All right. So you cannot use 6 and 2. All right. So for 27, it's going to be 9 times 3. So now the numbers that you could take the square root of, you take the square root of those, so it's going to become 2. This is the 2 outside. Square root of 4 times square root of 3. 5 times square root of 9 times square root of 3. So which gives you 2 times 2 square root of 3 plus 5 times 3 square root of 3, right? Square root of 9 is 3, square root of 4 is 2. So this becomes 4 square root of 3 plus 5 times 3, 15 square root of 3. So now they are like terms now because it's square root of 3 in both terms. So you add those two together, 4 and 15, that gives you 19 square root of 3. All right, so number 6. Want you to simplify 5 times the square root of 48 minus 2 times the square root of 27 plus 4 times the square root of 75. So the same idea here, you cannot subtract the 48 with the 27 because they're under the square root and they're not the same. So we have to simplify. So what perfect square divides into 48? Well, two of them do. 4 times 12 is 48, and 16 times 3 is 48. So when you have a situation where two perfect square multiply to um give you the when two perfect square multiply to give you the number, then you have to choose the larger one. So you want to choose the 16. If you choose the 4, no, there's not a problem there. You just have to do the work twice because 12 can also be broken down. So it actually would be 4 times 4 times 3, right? Because 12 is 4 times 3. And so you end up taking the square root of 4 twice. And that would end up being more work, right? So if you realize that there are two perfect squares, then you take the larger one. If you don't realize, then you just do the smaller one twice. All right, so here we're going to rewrite 48 as 16 times 3. And 27, what perfect square divides into 27? But we did that above, so that's 9. And same thing here, what perfect square? That would be 25 times 3. So we can take the square root of 25, we can take the square root of 9, and we can take the square root of 16. So that's what we're going to do now. So the square root of 16 is 4, so it's 5 times 4, and the square root of 3 is left inside. Square root of 9 is 3, and so a 3 is left inside. That's this 3 is left inside. And the 9 you take the square root of. And then plus 4 times square root of 25 is 5, and the square root of 3 is left inside. So you end up with 20 times square root of 3 minus 6 times square root of 3 plus another 20 times square root of 3. All right, so since the 20 repeats itself, well, might as well add those together. So 20 plus 20 is 40 square root of 3 minus 6 square root of 3. So you subtract 6 from 40, then you're left with 34. So 34 square root of 3 is the answer. All right. So one last one. So here, you want to simplify 3 times the square root of 20 minus the square root of 80 plus 2 times the square root of 45. The approach is the same. Currently, they are not like terms, so we have to simplify all the radicals. And hopefully at the end, they are like terms. If they are, we combine them. If they're not, then we just leave it as it is. All right, so is there a perfect square that multiply times another number to give you 20? So 20 is what times what? 20 is 4 times 5. We could take the square root of 5, 4. 80 now. That's a big one. So 80 is what? 80 is 16 times 5, right? So we can take the square root of 16, so that's fine. So 16 times 5. And then plus 45. 45 is 8 times 5 is 45. No, 9 times 5, sorry. 9 times 5 is 45. So we can write this as 2 times square root of 9 times 5. All right, so now we can take the separate it. This is 3 square root of 4 times the square root of 5 minus the square root of 16 times the square root of 5 plus 2 times the square root of 9 times the square root of 5. The square root of 4 is 2. We cannot take the square root of 5, so we leave it. Minus the square root of 16 is 4. And we leave the square root of 5. And then plus, we have 2 times the square root of 9 is 3. And then we leave the square root of 5. All right, so this gives us 6 square root of 5 when you multiply 3 times 2, minus 4 square root of 5, plus another 6 square root of 5. All right, so now we combine the terms. So if you subtract 4 from 6, you're left with 2 square root of 5 plus 6 square root of 5. And if you add those two together, you get 8 square root of 5. And that would be the answer. All right, so as usual, I have some for you to try and check your answer with mine. And if there's any problem, just type it in the chat.